Hey guys. Oh, just another wonderful edition of Patio Productions. Folks, we are going to continue our thought that we did in the previous lesson. We are in section 16-3. We're learning about tangents to curves. And in our previous lesson, we learned how to find the slope of a tangent line to a curve, which was just like super amazing. But today we're just going to push that just the teensiest little bit, where we now write the equation of that tangent line, which is actually just like one itsy bitsy teeny little step. Like literally, like you're going to find the slope, and then like it's going to be really easy to get the slope of the that equation of the tangent line. So let's just dive right in. We only have 2 examples today, and the instructional part is actually not that much. So let's just dive right in, right? Let's get this going here. And let's learn this next part of our unit. Okay, here we go. Now, remember, guys, we're doing this in bite-sized pieces, right? Bite-sized pieces so that I know that you guys are taking your APs and we're winding down. And so we're just doing it in little bitty chunks. So it's really important that you guys stay on top of things. And so this lesson is meant for Tuesday, May 12th, but, you know, you're doing it when you're doing it. But try to keep up with stuff, okay? So if we know the slope of a tangent line, we can then write the equation of the tangent line. I don't even know if you need to write that down, or you can just be like, knowing slope, I can write the equation, okay? So we're just going to be able now to write the equations of tangent lines. So what we're going to do when we write our equation tangent line, we're gonna find the slope, and then we're probably just going to write it in point slope formula, which is actually kind of easy and kind of lovely, okay? We're going to do one forwards example and then one sort of a backwards example, and then that will be our lesson for today. Just 2 examples, boom, lickety split, we're in, we're out. Okay, so this says find the equation of the tangent line. Now this time I tried to up the algebra a little bit by making it be a cubic graph, just because, you know, I want us to make sure that we know how to do like all the different like levels. So now this is a cubed graph, no big deal though, everything's going to be fine. So find the equation of the tangent line to this curve. F of x equals x to the third minus 2x squared plus 3, and then at the coordinate of 1, 2. If you plugged in 1, folks, you would, in fact, get a positive value of 2. Okay, so the first thing we're going to do is remind ourselves about how to find the equation of a line, okay? So to find the equation of the line, we need 2 things. We need a slope and we need a point. And I know you're not in calculus yet, guys, but if you were to come to calculus, I know that with my students all the time, I always am like constantly yelling this. What do we need for the slope? What do we need for the equation of a line? We need 2 things. And everybody says point and slope, or they say slope and a point. So we just need these 2 things, okay? I know we do a lot of like calling and answering, but yeah, seriously, guys, we just need to have 2 things, a slope and a point. Okay, well, guess what we already have? A point. Okay, the point is right here, done, boom, shakalaka, check mark that. But what I don't have is the slope. Okay, so we have to find the slope. So in our previous lesson, we learned that the way that you can find a slope of a tangent line is to take the limit as x approaches our c value. Our c value is a 1 this time. So the limit is x approaches 1 of f of x minus f of 1 all over x minus 1. We do our algebraic magic, and then we jam it. So let's do this, okay? This is going to say the limit as x approaches 1 of, here's f of x cubed minus 2x squared plus 3 minus f of 1 value is a 2. I got it right here from the point, all over x minus 1. Okay, we are going to then go like this. The limit is x approaches 1 of x cubed minus 2x squared plus 1 all over x minus 1. Now, anybody want to take a guess? Anyone? Do you know what number is definitely going to go into this top? And x minus 1. Okay, it is true that x minus 1 goes into it. How would you figure that out? You could do it a couple of different ways. Okay, you could do long division. I don't really feel like I want to do long division. Nah, I don't want to do that. What I would probably do on the side of my paper, like I know x minus 1 is going to be a factor, guys, because I'm going to cancel those. Okay, so I would probably do on the side of my paper is I would have put a 1 in the box. Remember how we do this synthetically? And I would go 1, and then I would do a -2, and then I would do a 0, and then I would do a 1, and then I would just go through. And what would happen? I would get a depressed equation of x squared minus x minus 1. Isn't that nice? Okay, what happens at this point right here is these do cancel 100%. I have the limit as x approaches 1 of x squared minus x minus 1. I can now plug in 1, right? Now I can finally plug in 1 and it doesn't zero out and becomes 0 over 0. And I'm going to get a 1, take away a 1, take away a 1. That is, in fact, a -1. Okay, so -1 is our slope. Okay, so let me see if I can actually get a different color here. Okay, so -1 right here is, oh, that was horrible. Let's just not have that on our paper. Give me a second, guys. That was ridiculous. I can't believe that it wasn't even a circle. I can't even believe that. What is wrong with me? I mean, seriously. Okay, let me try that again. Okay, so this is our slope right here, and I know it's kind of crowded up here, but this is our coordinate. Okay, so we have our slope of a -1, we have our point of 1 comma 2, and now I'm going to go ahead and I'm going to put this into the equation of a line. Okay, point slope formula says you're going to go y minus y1, which is the y coordinate, so y take away 2 equals m times x minus x sub 1. So this is -1 times x minus 1. Honestly, guys, you can leave it like that. Like, I'm not even kidding. Just leave it. Okay. Sometimes in our textbook, they'll go ahead and make that be into y equals form. I could care less. In calculus course, you get to leave everything as a y in point slope form. So just like that, that's how I want you to leave the answer. Ladies and gentlemen, we've answered example number 1. I'm very proud of us. Good job. Excellent work. Okay, a couple of little just like notes that we want to write down before we do one more example where we actually sort of like do this process backwards. I know, interesting. Okay, so our original question is how to find the slope of a curve. Okay, so here's the deal. The slope of a curve is actually the exact same thing. I know, be still my heart. Isn't this amazing? Okay, it is the exact same thing as the slope of the tangent line. Okay, so we were first asking how do you even find the slope of a curve? Okay, there's this idea, and it's in calculus, that if you zoom in enough on a curve, like keep on zooming in and zooming in and zooming in, that when you look at the graph, like even if it's totally curvy, it actually looks like a very little straight piece. It's actually true. You could try it on Desmos. You could graph anything and just pick a certain spot and then just keep on zooming in on it. And you're like, oh my goodness, if I zoom in enough, this little piece right here just totally looks like a straight line. Okay. And so if you're going to find the slope of a curve, the slope of the curve is actually the exact same thing as the slope of the tangent line, which I think is so amazing. Like, I just want to applaud it. I want to go ta-da. I want to be like, bum, 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 bum. I want to be so excited about it. Okay. The slope of a curve is the slope of the tangent line. Pretty awesome. Okay. So the slope of a curve might vary from point to point, right? It's not like always the examples that we've done so far, the examples that we did in our previous lesson, as well as the example we did today, were all at like one particular point. But as you slide around a curve, right, the tangent lines are going to have different slopes. Maybe if you're just even picturing a parabola, at first the tangent lines are going to be negative, then they're going to get real shallow, and then it might even go to like 0, and then it'll start being positive. So they shift as you go around, okay? So it's helpful to be able to represent it in generic form as opposed to at like a particular specific point. Okay. And so you're going to use an arbitrary point, basically just like C, and then you can use it with specific slope values. Okay. So this graph is doing, this example is doing things a little bit backwards. Okay. I know, so fun, so exciting. This one says, find an equation of a line where the slope is 5. That tangent line has a slope of 5, but we don't know where the coordinate is. Oh, yeah. So that's what we have to find out this time. Okay. So we're going to do the same thing we did. Like, the process is the same. Our algebra is the same. We're just doing it like a little bit backwards. Okay. So let's work our way through this question. This says f of x is equal to x squared plus 3x and then minus 1. So, okay, we have the slope, but we don't have the point. So we're going to have to use two general terms, f of x, which is like what we always use, and then f of c, right? So f of c right here, f of c is just going to be like just a general point. It's not specific, it's just general. Okay, and we're going to say that the limit as x approaches c of f of x minus f of c over x minus c, which is actually the definition of how you find the slope of the curve and the slope of the tangent line. We are going to then just plug in those formulas, okay? So f of x, of course, starting with, Mrs. Fox should definitely mention, we're starting with the limit as x approaches c. Okay, so right here, the limit as x approaches c, we write f of x. F of x is x squared plus 3x minus 1. If we do f of c, I just plug in the c value, and I get minus the quantity c squared plus 3c minus 1 all over x minus c. Folks, if I were to plug in c right now, Anybody guess what's going to guess is going to happen? It's going to become 0 over 0, which is nonsense. And so then we have to figure this out, okay? So we're going to do a little simplifying. I'm going to go ahead and I'm just going to distribute this negative to all of these terms and then maybe doing a little combining of terms here, okay? When I combine my terms after I distribute this negative 1 right here, this negative 1, and then this is going to turn to a positive 1 are going to actually cancel each other. And so what I get is an x squared plus 3x minus c squared minus 3c. All over x minus c. Again, I want to be able to do some algebra with this. So I'm going to reorganize it. And then maybe now you're like, oh, I kind of see some things that maybe I could do to like rearrange how this looks like algebraically. So when I rearrange this, I'm going to write the limit as x approaches c. I'm now going to have an x squared minus a c squared. So I'm just scooching things around a little bit. Plus 3x minus 3c. Let's kind of group these up. What could I do with this group of first two? What could I do with this group of the second two? I think the second two is kind of obvious. I could factor out a 3, but what could I do with the first two? Oh, I know. It's a difference of squares. Yes. So what I'm thinking is, we're going to make it look like this. It almost looks like more complicated than it really started out to be, but it's going to be so amazing, okay? I think I'm going to write down now the limit as x approaches c of my difference of squares factored, x minus c times x plus c, and then plus the 3 taking out of the x minus c. Well, guys, this is actually a binomial. Here's our first term and here's our second term. Do these two terms have something in common? And the answer is yes, they do. They both have an x minus c in common. It's almost like we're doing factoring by grouping kind of, right? So I'm going to take out that x minus c and then see what's left over. So now again, I'm going to write the limit as x approaches c. I factored out the x minus c and what was left? There was an x plus c, right? An x plus c was left over right here. And then there was a 3 left over. That's all that's left over. So now my x minus c's totally get to cancel. And so now I get this. The limit as x approaches c of x plus c plus 3. Okay, now, again, we're trying to find and make the x value approach c. Every time I was going to plug in the c for the x value on all the rest of this was going to be 0 over 0, but not now. Now I can plug in c for x. Okay, I know that's confusing, right? But this says as x approaches c. This c value is going to go in for the place of x, you guys. And we get c plus 3, which is 2c plus 3. In general, ladies and gentlemen, the slope anywhere on this beautiful parabola is going to be 2c plus 3. And so now we're just going to find the specific values of c that would make the slope, because this is what we were finding the entire time, turn out to be a 5. Okay, so we're doing where is 2c plus 3 equal to 5? If we do that, I'm going to subtract 3 from both sides. I'm going to get 2c equals 2 and c equals 1. Okay, so the coordinate now where the slope is 5, because guys, the question still was asking us, let's go back to this original question. Okay, the original question says find the equation of the line, right? And to do the equation of the line, we have to have a slope and we have to have a point. The whole time we had the slope. Okay, but we didn't have the point. We did all of this mathematics right here, all of this mathematics, so that we could figure out that the x coordinate of the point was equal to 1. Now what's the y coordinate? You're going to take your 1 and you're going to plug it into the original equation. And so if I do a 1 squared plus 3 times 1 is 3, minus 1, I get 3. So the coordinate is 1, 3. And then just like that, boom, we're going to be able to write the equation of the tangent line. And the equation of the tangent line is in point slope form. Y minus 3 equals 5 times x minus 1. Isn't that so pretty, you guys? Okay, so we have done 2 examples today. One was sort of like a forwards guy where we wrote the equation of the tangent line. And then this one was almost like a backwards guy, but still we were writing the equation of the tangent line. Nice work, everyone. Good job, good job. Okay, so today you're only going to do 21, 22, 23, 24, 25, 26. 6 questions, like no joke, okay? You are just going to do a whopping 6 questions where you practice writing the equations of the tangent line. I'm going to be very proud of the work that you're going to do. I'm going to be super excited. It's going to go so swimmingly, okay? I think this is going to be just awesome, awesome, awesome. And that's our lesson for today. Okay, guys, so stay in it. Remember, bite-sized chunks, manage your time, do all the good things. I miss you so much. I hope you're doing well out there. And I think that's it. If you have questions, of course, you're going to come visit me during office hours. And I think that's it. All right. Have a good one, guys. Bye.